When we look at the great structures of the past, we often feel a sense of wonder. How did people so long ago build such magnificent things? We see the Great Pyramid of Giza standing tall in the Egyptian desert. We see the temples of India carved from solid rock with incredible detail. We see the city of Machu Picchu perched high on a mountain in Peru. These places were built without the giant cranes and powerful machines we use today. They were built with simple tools, strong hands, and brilliant minds. The precision is astonishing. Stones weighing many tons fit together so perfectly that you cannot slip a piece of paper between them. This perfection makes some people ask if it was even possible for ancient humans to do this work alone. The mystery surrounding these creations has led to many imaginative stories. Some people suggest that ancient civilizations had help from aliens from other planets. Others believe they possess some kind of lost, magical technology that we no longer understand. These ideas are exciting, but they take away from the real story. The true story is even more impressive. It is a story of human ingenuity, careful planning, and incredible hard work. It is testament to what people can achieve when they work together toward a common goal. They understood their world in a profound way. They knew about mathematics, astronomy, and the laws of physics, even if they used different words to describe them. These ancient builders were masters of their craft. They were not just laborers piling stones on top of each other. They were engineers, architects, and artists. They planned every detail before the first stone was ever moved. They knew how to find the best materials and how to shape them with the tools they had. They organized thousands of workers, making sure everyone knew their job and worked safely. They created buildings that were not only strong and functional, but also beautiful and meaningful. These structures were often places of worship, tombs for kings, or entire cities. They were built to last for thousands of years, and many of them have. This essay will explore the real methods used by these ancient engineers. We will look at how they cut and moved enormous blocks of stone. We will see how they achieved such amazing accuracy with simple instruments. We will examine famous examples like the Kailasa Temple in India, the pyramids of Egypt, and the stone walls of Machu Picchu. By understanding their techniques, we can move past the myths and legends. We can appreciate the true genius of these ancient people. Their accomplishments are not the result of magic or outside help. They are the product of human intelligence, creativity, and the sheer will to create something that would stand the test of time. And the secret to ancient engineering was not a set of lost super tools. Instead, it was the clever use of simple machines and a deep understanding of natural principles. The builders had tools made of wood, stone, and soft metals like copper and bronze. They had chisels, hammers, and saws. These tools might seem basic to us, but in the hands of a skilled worker, they were incredibly effective. For harder stones like granite, they used an even simpler method. They would pound the stone with harder dolerite rocks, slowly wearing it down to the shape they wanted. This process was slow and required a lot of patience, but it worked. Moving massive stones was one of the greatest challenges. The ancient engineers became masters of leverage and friction. They used wooden levers to lift heavy blocks just enough to slide rollers underneath them. These rollers were usually logs of wood. Once a stone was on the rollers, a team of workers could pull it across the ground with ropes. To make it even easier, they would sometimes wet the path in front of the stone to reduce friction. They also built long ramps made of earth, brick, or rubble. These ramps allowed them to drag the stone slowly upward to the height they needed. It was a slow and difficult process, but with enough people working together, they could move mountains. Planning and organization were just as important as the tools. Before construction began, architects and scribes would create detailed plans. They used simple tools like plumb bobs, a weight on a string to make sure walls were perfectly vertical. They used square levels, which looked like a large letter A, with a plumb line in the chin in the middle, to ensure surfaces were flat. Their understanding of geometry was remarkable. They could create perfect right angles using ropes with knots tied at specific intervals, forming a 3, 4, 5 triangle. This knowledge allowed them to lay out the foundations of enormous buildings with incredible accuracy, ensuring everything would fit together perfectly. The power behind all of this was teamwork. Building a pyramid or a temple required a huge workforce. These were not just slaves, as is often imagined. Many were skilled craftsmen, masons, and carpenters who took great pride in their work. Others were farmers who worked on the construction projects during the seasons when they could not plant or harvest crops. They were organized into teams and divisions, each with its own leaders and specific tasks. They were fed, housed, and cared for. This massive coordinated effort of thousands of people, all working toward a single vision, is what made these incredible feats of engineering possible. In India, ancient builders created temples that seemed to defy logic. The Kailasa temple at Ellora is a stunning example. It is not a building made of separate stones stacked together. Instead, it is a single, gigantic sculpture carved out of a solid rock cliff. Imagine looking at a mountain and deciding to carve a temple out of it, not by building up, but by cutting away everything that was not the temple. The workers started at the very top of the cliff and carved their way down. This top-down method was a stroke of genius. It meant they never needed to build any scaffolding. The uncarved rock below them always served as their working platform. This incredible project required meticulous planning and a huge coordinated workforce. It is estimated that about 400,000 tons of rock were chipped away over many decades. Workers used simple iron chisels, hammers, and picks. They would carve deep trenches down into the rock, isolating the huge central block that would become the main temple. Then they began the detailed work of carving the halls, pillars, windows, and intricate statues. Every detail had to be planned from the start, because with this method there was no way to fix a mistake. Once a piece of rock was removed, it was gone forever. The result is the world's largest monolithic structure, a testament to incredible foresight and skill. Not far from there, the Lepakshi Temple holds a different kind of engineering mystery, the famous hanging pillar. In a large hall filled with carved stone pillars, one of them does not touch the ground. It hangs from the ceiling with just enough space underneath to pass a thin piece of cloth or paper. For centuries, people have wondered how this was possible. It was not magic or some unknown force. It was likely a brilliant and deliberate calculation by the builders. The pillar provides some support, but its weight is so perfectly distributed through the ceiling beams that it barely needs to touch the floor. It is a clever demonstration of their understanding of load distribution and structural mechanics. This pillar shows that the ancient builders were not just following old rules, they were experimenting. They were pushing the limits of their knowledge and materials. The hanging pillar might have been a way for the engineers to show off their skills. A signature of their mastery, it challenges our modern assumptions that precision engineering requires computers and advanced technology. The builders of Lepakshi used their deep practical knowledge of stone and weight to create something that still baffles and inspires us today. It is a small but powerful reminder that the minds of ancient engineers were as sharp as any in the modern world. The Great Pyramid of Giza is perhaps the most famous ancient structure in the world. For thousands of years, it was the tallest man-made building on Earth. It is made of an estimated 2.3 million stone blocks, some weighing as much as 80 tons. The sheer scale is honestly difficult to comprehend. How did the ancient Egyptians build something so massive with such incredible precision? The base of the pyramid is almost a perfect square, with its sides aligned almost exactly with the four cardinal directions, north, south, east, and west. This alignment was likely achieved by carefully observing the stars, a skill at which the Egyptians really excelled. The cutting of the stones is another area of fascination. The main blocks of limestone were quarried nearby. Workers would cut grooves into the rock, then insert wooden wedges. They would soak the wedges with water, causing the wood to expand and crack the stone along the desired lines. For the harder granite used in the inner chambers, they used a more laborious process. They pounded the granite with dolerite balls, which is a type of rock that's even harder. They also may have used copper saws, feeding sand into the cut as an abrasive to help grind through the stone. It was slow, painstaking work, but it produced blocks that were remarkably straight and smooth. Moving these giant blocks from the quarry to the construction site was, well, a monumental task. For stones quarried far away, like the granite from Aswan, they were loaded onto large wooden boats and floated down the Nile River. Once at the Giza Plateau, the blocks were dragged across the land using sledges. Recent discoveries suggest that workers would wet the sand in front of the sledge, which made it much easier to pull. To lift the stones up the growing pyramid, they built enormous ramps. Scholars still debate the exact shape of these ramps. Some think it was a single long straight ramp, while others believe it was a spiral ramp that wrapped around the pyramid as it grew. The placement of the stones is where the Egyptian skill truly shines. The blocks fit together with mortar joints that are incredibly thin and precise. Inside the pyramid, the passages and chambers are masterpieces of engineering designed to bear the immense weight of the stone above them. The king's chamber, for example, has 5 stress-relieving chambers built above it to redirect the pressure and prevent the ceiling from collapsing. This was not guesswork. It was the result of generations of experience, trial, and error. The pyramids are the ultimate proof that with careful planning, simple mechanics, and a massive organized workforce, ancient people could achieve the seemingly impossible. High in the Andes Mountains of Peru, the Inca built a city that seems to grow out of the very rock it stands on. Machu Picchu is a marvel of civil engineering and stonework. It was built around 1450 AD on a narrow ridge between 2 mountains, a location that is both breathtaking and honestly kind of dangerous. To build a city here, the Inca first had to reshape the mountain itself. They created hundreds of agricultural terraces, which were not just for farming. These terraces stabilized the steep slopes, prevented erosion, and helped manage water drainage. This careful preparation of the foundation is a key reason why the city has survived for over 500 years in a region prone to heavy rains. The most famous feature of Inca architecture is their incredible stonework. The builders used a technique called ashlar masonry, where stones are cut to fit together perfectly without any mortar. In some of Machu Picchu's walls, the stones are so precisely joined that you cannot fit a knife blade between them. The stones are not simple cubes. They are complex, multi-sided polygons that lock together like pieces of a giant jigsaw puzzle. This method made the walls incredibly strong and stable. The Inca did not have iron or steel tools. They shaped these hard granite stones by patiently pounding them with smaller, harder river stones, a technique known as stone-on-stone abrasion. This unique construction style also made their buildings remarkably resistant to earthquakes, which are, pretty common in the Andes. During an earthquake, the stones in an Inca wall can dance. They move and shift with the tremors, then settle back into their original positions once the shaking stops. A rigid wall made with mortar would crack and collapse under the same stress. The Inca understood their environment and designed their buildings to work with the forces of nature, not against them. This deep connection to their surroundings is a hallmark of their engineering genius. They built structures that were in harmony with the challenging landscape. Building a city in such a remote location also required incredible logistics. The granite stones were quarried on site, but moving the multi-ton blocks up steep slopes was a major challenge. The Inca used the same principles as other ancient cultures: manpower, ramps, rollers, and levers. They carved temporary footholds and pathways into the mountainside to help workers drag the stones into place. Every part of the process, from quarrying to shaping to final placement, required immense effort and coordination. Machu Picchu is more than just a beautiful ruin. It is a powerful example of how human beings can adapt and build enduring masterpieces in even the most difficult environments on Earth. The enduring mystery of ancient monuments has often led to fantastic theories. Tales of levitating stones, advanced alien technology, or forgotten sonic weapons are certainly entertaining. However, these stories do a great disservice to the real builders. The truth, as uncovered by decades of archaeology and experimental science, is far more impressive. It lies not in otherworldly forces, but in the boundless potential of human ingenuity, patience, and collaboration. Archaeologists have found the tools the builders used, the quarries where they cut the stones, and the remains of the ramps they built. They have even found the villages where the workers lived, giving us a clearer picture of their daily lives. Scientists and engineers have put these ancient methods to the test. In experimental archaeology projects, teams have successfully replicated the techniques of the past. They have moved multi-ton blocks using only wooden sledges, ropes, and manpower. They have cut granite with simple copper tools and sand. They have built small-scale pyramids and raised massive stones using the same types of ramps and levers that the ancients would have had. These experiments prove that these methods, while slow and labor-intensive, are completely effective They show that you do not need lasers or anti-gravity machines to build a pyramid. You need a good plan, a lot of people, and a deep understanding of basic physics. The real lost technology of the ancients was not a machine. It was a way of thinking. It was an accumulation of knowledge passed down through generations. Master builders learned from their predecessors, adding their own innovations and refining techniques over centuries. They possessed a level of patience that is hard for us to imagine in our fast-paced world. They were willing to undertake projects that would take decades or even lifetimes to complete. This long-term vision, combined with a profound respect for materials and natural laws, is what allowed them to create structures of such beauty and permanence. Their genius was practical, observable, and very human. Ultimately, these ancient masterpieces inspire us because they are a monument to human potential. They remind us that our ancestors were not primitive or simple. They were intelligent, creative, and capable of incredible achievements. They faced immense challenges, hard stones, steep mountains, and the simple force of gravity, and they overcame them with their minds and their hands. The pyramids, temples, and mountain cities are not puzzles to be solved by looking for aliens. They are a legacy written in stone that tells the story of our own shared human capacity for greatness. They stand as timeless proof that with vision, cooperation, and perseverance, there is no limit to what we can build.